I would like to introduce Professor Prithvi Singh Kandhal, who is currently the Associate Director of the NCAT, which is National Center for Asphalt Technology, which is based in US. And NCAT, if you were to be precise, is the largest asphalt road technology center in the world. And prior to NCAT, he has served as the Chief Asphalt Road Engineer of the Pennsylvania Department of Transportation for 17 years. And he has served as a President, International Association of Asphalt Paving Technology, and also as the Chairman, American Society for Testing and Materials International Committee on Road Paving Standards, and Chairman, US Transportation Research Board Committee on Asphalt Roads. And also recently he has developed new standards for IRC, which is Indian Road Congress. He has also got a Lifetime Achievement Award in Asphalt Road Technology from the International Association of Asphalt Paving Technologists during the annual banquet held in Austin, which is at US. We have invited him personally here because based on the requirements that we have received from the site, wherein they wanted to learn more about the advancement in the construction technologies and how advancement in the construction technologies and also about the maintenance. So over to you, sir. So you can actually highlight.
Thank you very much.
Thank you.
Bituminous pavement distresses, causes and cures. This is a very old picture, you know. You know that if we don't have any pavement, then we don't have any distress. So life is very simple, but at the same time it's very complex. You guys in NHI, you know, won't be on the job if you have roads like this one. Yeah. But today we do have pavements, and that's why we are going to discuss the distresses in the bituminous pavement. Bituminous pavement distresses can be minimized if a basic requirement for flexible pavements are met. And these are the basic. Okay, we are saying that bituminous pavement distresses can be minimized if basic requirements for flexible pavements are met. And these are the basic requirement. Many times our highway engineers say that three things are important for a good performance of pavements, and those three things are drainage, drainage, drainage. That means we cannot overemphasize the role of drainage in the performance. The second point we have is sufficient thickness and internal strength to carry out the expected traffic load. This means that we got to do a good pavement thickness design for the load to minimize these kind of problems, and also the internal strength of the mix should be okay. So the mix should have adequate stability and all that should be very strong. The third thing is adequately dense to prevent penetration of moisture from underneath, sides and surface. In other words, your bituminous mix should be very dense. Now that kind of rules out BM. You cannot use BM, bituminous macadam. You cannot use semi-dense SDBC because that's a semi-dense. And there are many other. You cannot use DBM grading 1. DBM grading 1 takes in water. I've seen that. You know. It fails prematurely. So it's not sufficiently dense. So you got to use DBM grading 2 only. So the third point is very important. That rules out all these bad mixes from our books, but they are still on our books. And the last point is the top surface should be smooth, waterproof, skid resistant, resistant to wear, distortion and deterioration by weather. And I think that's all common sense. We understand that. These are the general causes of bituminous pavement distresses: poor quality of materials and construction. And that's what we talk about for the last 2 days, you know, just to make sure that we have good quality materials and good quality construction. Inadequate pavement thickness, that's the same point we discussed last slide. Amount of traffic and its rate of loading. Rate of loading means, you know, that your mix might be okay for fast traffic, but sometimes near the stoplight or when the trucks are going very slow on a steep grade, we might have some rutting problem. So that means that mix is not designed for a slow rate of loading. And fourth is aging of asphalt binder. Now we cannot, you know, actually binder will always age, but We can minimize that by making sure that we have a good compaction at the time of construction. And then the effect of climate will also cause many distress, like in Rajasthan is a hot climate, Ladakh area is a cold climate. So they have their own manifestations of that. It's a very simple slide showing the stresses and strain. The main thing you see at the bottom is that just below the load you can see that in the bituminous layer or asphalt layer, at the top we have compression, at the bottom we have tension. So this whole pavement has different types of stresses. And then if you go on the right side, just right side, where the surface is kind of rising, then we have reversal of stresses. On the top we have strain, and then at the bottom we have compression. It's a very simple thing, actually. It's a very much simplified thing, but the main idea here is that at a particular spot we do have a reversal of stresses. We have compression, then tension, then compression, then tension, and that really is very much detrimental to the performance of the pavement. So now we talk about the typical distresses in bituminous pavement, and we can categorize them in a different distress mode. It can be like a fracture, can be the distress mode, and under the fracture we can have cracking, or we can have a spalling. Cracking can be load associated fatigue cracking, non-load associated, which is thermal cracking, or reflection cracking, and we will talk about these individually later on, and spalling. Then we can have the second distress mode is distortion. The material is still there, but it has kind of moved, just like we have the permanent deformation, under which we have densification, we have creep, which is rutting and shoving, corrugations, swelling. So the material has distorted in place. And then we also have slippage cracks, slippage which is also a distortion. And then the third distress mode we have is the disintegration, where the material is kind of simply disintegrating, it's being destroyed sort of. And under that we have raveling, scaling, stripping, and potholes. And we will discuss these things one at a time. And there's other distress mode like miscellaneous type, where we have a reduced skid resistance. I might build a very good pavement, everything is fine, very durable, highly durable, but if it becomes slippery when wet, there can be a lot of accidents. So that's not desirable. That's also a distress sort of. Then the riding quality, roughness is also important. So first we talk about the first distress mode, which is cracking of bituminous pavement, and we'll talk about load associated or fatigue cracking, first type of cracking. Then we'll talk about thermal cracking and all those. So this one is the fatigue cracking. It's also called alligator or map cracking, the way it appears on the surface, or like on alligator skin. And this would be caused by loads too heavy for the pavement structure. Like we didn't do a good job of pavement thickness design, or there might be overloading and all that. Second is too many repetition of load more than the design. It's the kind of same as the point one. Inadequate support, pavement layer, subgrade might be bad. The whole thing, subgrade might be settling. Your asphalt layers might be okay, but subgrade is settling. Poor drainage, very stiff binder in surface course, and this will occur in the wheel path, and ultimately sometimes the potholes will also develop in advanced stage. So that's it. Let's take a look at, here is the interstate highway in the US, and you can see in the right lane you can see some longitudinal fatigue cracking. It's not very clear, but you see in the right lane, in the wheel track area, you see that there's an initiation of fatigue cracking, and there's some raveling also associated with that. And then in the advanced stage, you can see some parallel longitudinal fatigue cracking will occur. So there will be like not one but many of them, and then ultimately there are more parallel cracks, then there are cross cracks, and then that's when it starts to look like a alligator cracking. And this is really in a very advanced stage of fatigue cracking. And this kind of pavement is just kind of already shot, nothing you can do. Just simply putting a overlay on top of that is not advisable. We got to do something about the pavement which is completely broken. We might have to go for cold recycling or whatever. There are several ways we can improve that. And here is a close-up of the fatigue cracking. It's also called, as I said, chicken wire cracking or alligator skin type appearance. And there's one more view of fatigue cracking, very close. So that was the fatigue cracking. It was the load associated. Now we talk about the known load associated, which is thermal cracking. Happens from the temperature. You may or may not have load. Even if you don't have any load, you simply built a new pavement, it has not been even used by traffic, you can have thermal cracking. So this will occur at regular intervals. These are transverse cracks. They are not unlike the fatigue cracking, which was longitudinal. These are transverse cracks. And these will happen if the asphalt binder is too stiff at low service temperature. We talk about the first day, that sometimes if the asphalt is very stiff at high temperature, neat bitumen binder, it can also be stiff at low temperature as well. That's where sometimes these polymer modified bitumen help us. Second point is rapid chilling of the road surface. If there is a sudden drop in temperature, like you might have in Ladakh or Leh area, the temperature might be like minus 30 degrees Celsius and goes to minus 40 degrees Celsius within 1 hour. So that's a rapid chilling, and you will see transfer crack all over the place. Just in that 1 hour it will take place. Next day morning you go on the project. This kind of happens quite often in the US. We don't have this problem in India, but in the US a lot of cold wind come from Canada, and all of a sudden chills the surface, and you have thermal cracking all over the place. Next day you go on the project, you see transverse crack all over the place. Fortunately, we don't have this problem in India, except maybe in Jammu and Kashmir, and that's where we are advising the Northern Command of Indian Army. I was there a few months ago, how to prevent in Ladakh Leh area. Then third point is a highly temperature susceptible asphalt binder, and sometimes subgrade can also affect it. Somehow we don't know if you got a clay subgrade or sandy subgrade, there are more cracks on sandy subgrade. It's very hard to explain why it happens. And last point is the age of the pavement. As the bitumen binder becomes oxidized, becomes more and more stiff, then the pavement is more susceptible to thermal cracking. So here you can see a typical thermal cracking in the US. You also see the snow, the white ground is white, and you can see these transverse cracking at some regular intervals. Stiffer your bitumen binder, closer are these transverse cracking. So the spacing of these transverse cracking will depend upon your stiffness at that particular low temperature. Now here, nothing much, but here is a white paint stripe in the middle of the road to divide the two lanes, and I can see at the edge of the white stripe I have some hairline cracking. Could somebody tell me why this is occurring? It's not a big issue, but can anybody tell me that why I see through parallel cracks, like at the edge of the white stripe and the black asphalt surface? Why I am saying this hairline cracking? Can you just guess? Huh?
Bitumen deficiency.
No, this road is same, paved with one paver. I just put a white strip, On a new road, I put a white strip, paint strip. We always put that,
Road marking.
Road marking, And then after 2 or 3 years, I see this hairline. It doesn't occur all the jobs, I'm just I'm asking you, Can anybody out there in Pali and other places can explain why I'm getting this hairline cracking at the edge of the white stripe?
Difference in thermal conductivity.
Yeah.
Sir, because of that, this is the moisture induced effect, sir. Because of the poor shoulder and water penetration.
Why the water will penetrate right at the edge of the paint stripe, Well, we have the answer here.
Maybe the shoulder, sir.
It's not at the shoulder, it is the
Maybe the
center.
shoulders are higher than the pavement, sir.
No, it's in the center.
Or improper shoulder connect.
No, this marking is in the center of the pavement.
Mark in center of the pavement.
Centerline marking.
Centerline marking. To divide the two lanes,
Yeah.
Well, we got the answer. We got the answer here is that when the sun is out there, the pavement under the white, won't get heated that much, as the black surface. So these white surface and the black surface have a different coefficient of expansion and contraction.
Thermal conductivity.
Thermal conductivity.
Yeah.
And because of that differential thermal conductivity, we have this hairline cracking. Now who guessed that? Yeah, okay. It's just to think about it. It has not much to do with actually pavement distress, but just to see that these kind of things can happen. Now we also have we have the longitudinal cracking. We talk about the fatigue cracking, we talk about the thermal cracking. Now we have longitudinal cracking, which will occur parallel to the center line of the roadway. And we have at least two types. One is the centerline joint, which is the longitudinal joint, which we discussed yesterday, how to construct a good joint and all that. So it will occur at that centerline joint. The other one will be edge cracking. So centerline joint, that's a joint between adjacent lanes, as we discussed yesterday. And one of the reasons why it happened, besides poor construction, is that there is a density gradient across the joint. When I construct one lane, first lane, my edge on the side of this next lane is unconfined. So when I'm trying to roll it, the mix pushes out, so I never get good density at the edge of the first lane. And then when I lay the adjacent lane, then there's a confinement. So at the edge of this next lane, the density is higher. So I have a density gradient across the joint. And because of different density, again, there is a different expansion and contraction. It will behave differently. Right, Professor?
Yeah, that's it.
Yeah. So because of that density gradient, that joint kind of opens up, So because we are low density on one side, but it can also happen from poor construction of the centerline joint, which we discussed yesterday. The second would be edge cracking. If I have a lack of lateral support, there will be edge cracking, which will also be parallel to the edge of the pavement. Settlement of widened pavement and poor drainage. Settlement of widened pavement, because when sometimes we widen the existing pavement, we have dissimilar material which we widen, so that crack always occurs and nothing much we can do. It keeps on, is a permanent nuisance sometimes. So here you see a typical longitudinal joint cracking. I mean, this joint was okay when it was built, but after 1 year, 2 years, 3 years, it starts to open up. And then after a few years, you got to seal it. It will happen more. I don't see that more in India. It happens more in cold climate countries more. It's a problem in the US, northern US. In India, I don't see it that much. Here is the edge cracking. Most likely it happened because I widen the pavement on the left side. On the whitest you think is the shoulder. This is not a good picture, but the whitest on the extreme left is this shoulder. But this edge cracking is about like maybe 1.5 to 2 feet from the edge due to widening. Then we also have block cracking. Block cracking means I have both transverse and longitudinal cracking. Most time it will happen on low volume roads or parking lots which don't have enough traffic. Our road always needs traffic. Traffic helps the road. I'm not talking about overloaded trucks, but we need some traffic. I can build let's say I build two roads, side by side. On one road I open the traffic, another road doesn't have any traffic for 2 years. You will see that the block cracking will start to happen in the other road which doesn't have any traffic. This is happening because there is a thixotropic hardening takes place or structuring takes place in the bitumen binder due to lack of traffic and heat. In other words, the bitumen is just laying there, no traffic, no heat. It's start to become stiff. There is apparent stiffness kind of develops, due to structuring, and that's why we have this block cracking. And you can see this on the driveway. This is a driveway for the house, and the house won't have much traffic. Maybe car might go out, come 3-4 times in a day. That's it. There's no traffic. So that's where you see this kind of block cracking. You might see this kind of block if you look closely on the airfield runway. If you look at the shoulder of the runways, you will see this kind of block cracking because there is no traffic on the airfield runway shoulder. So that's a close-up of the block cracking in a typical parking lot, asphalt parking lot. Then we go on to the reflection cracking. These are the discontinuities in the underlying layer which propagate through the asphalt surface due to movement of the cracks. So if I have, and this discontinuities might consist of cracks or joints in the underlying concrete pavement, cracks in soil cement base course, or any types of cracks which are already there in the existing bituminous pavement. If I am putting an overlay and the existing BC might have a lot of cracks, it will reflect through the new BC layer, and cause is the thermal because of these cracks and joints are moving. In the summertime they expand, so the width of the crack is less. In winter time is more, and then the load is also a factor. When load comes from one side of the crack to the other side. One thing which kind of strikes me that now we are kind of promoting soil cement base course, and in the US it was also used many years ago, but after many years it started to haunt because of the cracks. Nothing you can do. Now we are trying to emphasize soil cement. So here is a typical reflection crack. Actually we don't know, there is a cement concrete underneath, so we don't know whether it's a thermal crack which is also transverse, and or whether it's a reflection crack due to joint in the concrete. So if you take a core at that point in time, at that point, in this case you can see the crack in the bituminous concrete, but there is no joint in the concrete underneath. So most likely that crack in the asphalt concrete is due to it's a thermal crack. So you can find out pretty quickly. Wherever all the concrete pavement in the US, when they start to fail, the only thing you can do is just put a asphalt overlay on top. Asphalt always come into rescue when the concrete pavement fails. And one of the failures is like these reflection, the joints get bad. So when we put the asphalt for the first time, that reflection cracks also is a nuisance, and we have to keep on sealing it. One way to avoid that, which you see in this picture, is that when you put the BC layer on top of the concrete, you make a saw cut right above the concrete expansion joint, and you make a saw cut and you fill it with a joint sealer, and that's a good answer to that. Then that takes care of that problem. Otherwise, you keep on getting reflection crack, you keep on sealing and all that. So here is a called saw and seal method to minimize the reflection crack problem. So how do we treat these cracks, which are different kinds? Cracks should be sealed as soon as possible, so there is no water penetration in the pavement, which may cause further damage. Asphalt rubber is considered the best material for sealing cracks. Now that's pretty common in the US, but I don't see in India, I have not seen much use of asphalt rubber. And we'll talk about that in the maintenance. Next lecture we'll cover this more, like what kind of material we should be using for cracks. Now, once we have a reflection crack or thermal crack, sometimes you start to see parallel cracks, and between the parallel cracks you can start to see spalling, like chipping away of the asphalt concrete, like in this case, it's kind of lost, now, this could have been avoided if I had sealed the crack when it appeared first, But if I don't do that, if I don't do anything, then this kind of a spalling or chipping off will take place. And now we'll talk about rutting. Rutting can be lack of adequate subgrade support. It can be unstable asphalt course itself, which can be poor mix design, rounded aggregate, excessive asphalt binder, and stripping in the asphalt courses, and we'll see some pictures in there. But before we talk about rutting in detail, let's talk about the bleeding, because sometimes the bleeding may or may not lead to rutting. I've seen the bleeding takes place first and then the rutting follows, and it's not necessary that will happen. So here we have a picture of bleeding, which sometimes, not always, precedes rutting. And I have seen in many of our national highways, and you might have seen as well, bleeding. One more example of bleeding. It can also be flushing. There's some people say flushing and bleeding. To me, flushing is just like a start of bleeding. Like you see a sheen of bitumen on the surface, and sometimes that sheen can wear off, and you are okay. But sometimes it can lead to more like bleeding, and then you got to do something about that. So what do we do if I have some bleeding on the national highway? I use too much bitumen or whatever. So what I can do is apply hot sand and roll it during hot weather to blot out extra asphalt binder at the surface. So you do it one time. You can get the hot sand from your hot bins, You can get hot from hot mix plant, pull off some stone dust, from the hot bin, so it's already hot, and try to roll it. You have to do it 2 or 3 times. If it doesn't help you, then you just pray. Nothing will. It may or may not work. If it doesn't work, then you got to place some surface dressing on the bleeding asphalt surface. That's the chip seal. I know you cannot do that on the national highways, but on other pavements you can use surface dressing, or you can place slurry seal on the bleeding asphalt surface. I mean, these might be better than milling off the entire bleeding pavement. So here you see a rutting. It's resulting from subgrade. It's not, the rutting can take place within the asphalt layer, or it can come from the subgrade. In this case, my guess would be, and I think the guess would be right here, that it's coming from the subgrade, because you see a bridge, nearby. Mostly when we construct the bridge approaches, we don't do a good job of compaction of subgrade. Construction is not that good. So that's what happened here, is that in the approaches which we built the last, after the amendment, everything was finished, and most likely it was the subgrade. Also, when this happens, then the rutting is very like abrupt. It's not like very smooth. You can see the edges. So most likely it's the subgrade happening. Now this one is a picture from the US, and you saw it 2 or 3 times yesterday and before that. This is the rutting within the asphalt courses. It's pretty smooth. You also get like a hump on the side of the wheel track. So sometimes by appearance you can figure it out, what's happening. Not always, but sometimes. Now this is a interstate highway in the US, in the state of Pennsylvania, between Pittsburgh and Philadelphia, and it is a 4-lane highway, and 2 lanes were being reconstructed, so all the traffic was on these 2 lanes. What they were doing was that it was a concrete road. They used 25 millimeter of a leveling course, which was like a BC grading 2, and then 50 millimeter of a DBM grading 2 type binder course, and 40 millimeter of BC. So these 3 layers are put down on concrete. It carries very heavy traffic. So within 2 or 3 months, there was rutting about like 25 millimeter. So since I was the chief asphalt road engineer, the district engineer called me. He said, "What do I do? There's a 25 millimeter rutting. Should I remove the BC or should I remove the BC and DBM?" I said, "I'm not a god, I cannot tell you anything. I need a cross section, you to saw cut, You see the black strip on the bottom side. I said, make 2 saw cuts, like 12 inches apart, and we'll cross cut and get the slabs, blocks out of it, and then I will take a look at all these 3 layers, that where. If I tell you that only BC is rutting, then and then you remove the BC, and we might find out that DBM is rutting actually. So I don't have any idea. This he said, no way I can. It will take like 2 hours to cut this slab, and the traffic is already on 2 lanes, and so I said, nothing I can do. I cannot help you. If you remove both DBM and BC, it might be overkill. It's a long job. So finally, they diverted the traffic to back roads, and they took these slabs out, and we. At the bottom, you see the one which was rutting. On the top, there was hardly any traffic. So in the bottom, we joined all these blocks in that one lane, and you can see the rutting in the wheel track area. It shows the wheel track area, and it shows all the 3 layers. We put some white paint, we demarcated the. So you can see here in the bottom assembly of these blocks that besides the you see the wheel track rutting here, and here there is heave there. So you can see here that the rutting is taking place in the binder course. Here the thickness of the binder course DBM grading 2 is less in the wheel track and more at the edge of the wheel track, and the BC is just simply riding on it. So
We are seeing some other place.
oh yeah, they are showing. Yeah, you are right. You are right. They will understand that. You want to check that everybody is looking at the same slide.
Mr. Murthy, you got the slides now? Proper slides only, no?
40. Slide number 40.
40.
40.
40, slide number 40, because we are able to see your slide actually, which is showing some other slide. That's what Professor has pointed out.
Not that. Yes.
Okay.
There, since they have
Yeah.
all the slides.
So I'll repeat what I said before, that we took out slabs out of the pavement to find out whether the rutting is taking place in the BC or DBM, one of these two or both. The only way you can find out is really dig up a trench, and look at that. So we cut out the blocks out of it, and in the lower layer, which shows the rutting, forget about the top layer. It came from an area where there was no rutting, maybe no traffic. In the bottom layer, you can see a wheel track where the rutting has taken place, and there is a heave on the side of the wheel track, and there you can see that the rutting took place in the DBM. The thickness of the DBM in the wheel track is much less, although it was like 50 millimeter, but maybe it's less than that, and on the side of the wheel track is much more, whereas BC is this 40 millimeter all the way through. BC is simply riding over the DBM. So the DBM had rutted. If I have taken a guess, and told the district engineer just remove the BC, I would have been in trouble, Well, then they will put a new BC, and the DBM is the one which is rutting, causing rutting, So that way, I told them that you got to remove both BC and DBM. So sometimes, you have to do some investigative work to really tell. You cannot speculate. If you speculate, then one can be wrong. And here you can see, here is a close-up. Here is a close-up of the rut area and the area which has heaved on the side. You see the number 9 on the right side of number 9 is the heaving, and here you can clearly see that BC is okay. Only the DBM has rutted and is kind of heaving on the side. And if we take a look at the close-up, of the DBM, what do you see? What's the problem in the mix here in the DBM? Why the DBM is rutting? Why this DBM? You see the DBM, this second layer from the top. This is the one which is caused rutting on this project. You see the particle shape. The DBM has all rounded particles, and that was the main cause. And when we found out that why it happened, he said that the contractor by mistake got aggregate from Ohio state, which was next door. That's where it is coming. So he used the wrong stockpile, Anyway, so we said it's not our fault, so he had to correct that. So,
stability of mix, sir.
Pardon?
Due to the rounded particles,
Yeah, due to this rounded particle, and also there are many factors. Then we have to change our specification right away after this failure. We started to apply 75 blows. Before that, we will apply only 50 blows. And then we said no more natural sand. We tightened our specification right away after this big incident happened. We came up with a heavy-duty asphalt mix design where put all the no sand, nothing. These 75 blow and put in new specifications out of that. So we learned from that. Now this one is just a when we have rutting, what kind of shape you see on the surface when you are out on there. Now these are not necessary all the time. It will happen. If you have on the top, there are 3 examples here. On the top, we have a plastic movement depression in the wheel path with humps in either side. Now this one is the rutting which is taking place within the asphalt layers, whether BC or DBM. So it's like a plastic movement within the asphalt layer, very, very smooth. You also see hump on the either side of the wheel track. Second one is the consolidation or densification depression in the wheel path without any humps. Now this might happen in your asphalt layer if I didn't do a good compaction job. Well, yesterday we talked about that no more than 8% voids. If I'm a lousy contractor, I had like 10-12% air voids in there, much more than that. Then the traffic will densify that, and it will densify more in the wheel track area. So you might see some slight densification or consolidation, although it's not that much, and you may not notice it's not too much anyway. But it can also happen, and you can also call it rutting, although it may not be that deep. The third example you see in the lower is mostly mechanical deformations, subsidence or densification in the unbound base or subgrade. Your WMA might be a problem, your GSB might be giving a problem, or your subgrade might be giving a problem due to high moisture content, wrong gradation, not good compaction and all that. But here what we will see here is that mostly on the surface it's not very smooth, just compare that with the top one, and sometimes it will be accompanied by some cracks at the edges. These are just rough guidelines, they are not true all the time, but most of the time they will be okay. So the treatment for rutting, first we determine the cause and location of the rutting. We must, if the rutting is coming from the subgrade and you say, well, it's coming from the asphalt layer, then you are not solving the problem. Any layer exhibiting rutting must be removed completely and replaced with more stable mix. That's just a common sense. Now we go to slippage cracking. These are associated with slippage mechanism. It can be due to poor bond between the surface layer and underlying layer. Like if I get a poor bond between BC and DBM, it will happen. It will happen if I got too much tack coat or too little tack coat. It will happen mostly on steep grades and intersection, because that's where the acceleration and braking are taking place, which exert surface traction forces, and they will be like U-shape. You can recognize them by U-shape, and I'll show you some pictures of that. and to rectify them you got to do some patch repair. You remove those slippage cracks and do a patch repair. And here is one example of slippage crack. You can see that these are in the U direction. Another very bad example of slippage crack. It will be there are many causes, but main thing would be the lack of bond between the BC and DBM, the two layers, asphalt layer, because of too much tack coat or less tack coat. But the other thing is the traction forces. It will happen on steep grade. If you have intersection, traffic light, all of a sudden traffic light turns, red. Everybody is, stopping, applying brakes. So there is a lot of traction, shear force, horizontal shear force taking place. That will cause the movement, relative movement of BC and DBM. You can say that might be the main cause, But especially if you don't have good bond, or you are taking off, Yeah.
Investigating is only due to tack coat. How to investigate at this stage, because we don't know whether.
Okay, if you don't have any problem with the slope or whatever where people are braking or and it's happening on a horizontal highway, right? Now then most likely is the tack coat, lack of tack coat. And what I would take is the rough thing is that you try to take a core. You try to take core. Normally, if good bond, you get BC and DBM both at the same time, and you have to really make a lot of effort to separate them. If the core comes out very clean, that's clearly shows you that either there was no tack coat or too much tack coat, problem with the tack coat, or when you applied the tack coat, this DBM was dirty. Yesterday we talked about dirty surface. We didn't clean it, all that. So the very rough way to find out, very easy, just take a core, and if they both don't come out together, you got a problem. Yeah.
9%
Huh?
9% of the cases, BC and DBM we can't separate easily. But
Won't separate easily, no.
if you see any construction, we will take core of BC easily. Side.
Yeah. Can you say it again?
Yeah, Murthy sir.
Huh.
Sir,
Yeah.
We are taking course in BC, no sir, after execution.
yes, sir.
So is it how hard it is to take a course?
No, actually we can do the core cutting after completion of the BC, 24 hours after. And yes, it is true that it is very difficult to bifurcate DBM and BC. If tag code is there, then we can take it out, sir. It's not an issue, sir.
How hard we are?
No, his question is, in our case, are we able to take the core? Are we able to take core easily or difficulty? That is what the
Only of BC.
Difficult.
So what you are saying is that when you take a core, the DBM always comes out with the BC, right?
Yeah.
Okay, so that means you got a good construction, okay?
Yeah.
If it BC separates very easily, you got a problem.
Correct.
And sometimes you might see fatigue cracking as well, because the pavement thinks that it's made up only of BC. It doesn't work like a monolithic, thing. Yeah. Okay, so here is a good picture of one more slippage cracks. Now this checking I throw in there, because this checking, you see the hairline cracking. Sometimes this you will see it right away when the compaction is being done. After all the compaction is done, you see the hairline cracking, and with time, it can become somewhat widening. Prof. V. Raghavan and I saw this on DBM in Tamil Nadu a few years ago.
Yeah.
And they had done a lot of work on the DBM already. If I see this kind of checking after I'm done with the compaction, I should do something right away at that point in time. Why should I continue my job, and they didn't stop, So this kind of a checking will occur during compaction. So what can be the cause of that? We got to do something about the way we are rolling it, So why it's happening? It might happen sometimes because the mix is not taking weight of the roller, you know. So either I have to back off, you know. So the mix kind of cools down a little bit, and it can take weight. Otherwise, the mix kind of keeps on moving, you know, and it develops these kind of crack. Or my mix might have too many fines in there. There are 3 or 4 several reasons, you know. So if this thing is happening at the time of compaction, I must do something about it. I might, if I am using the vibratory compactor, I might have to do static rolling first, so the mix can carry the weight of the roller, and then turn the vibratory. And so many things can be done at the time of rolling. Everything not fixed, you know, in the asphalt, you know. You have to do certain things, different things on different jobs. Somehow you have to change your rolling so you don't get this kind of checking. They call checking in the US. Checking is nothing but hairline cracking resulting from the compaction. Corrugations, lack of bond between asphalt courses, it happened because of that. Unstable surface course mix. But again, it will happen mostly because of the braking and accelerating action near the intersections. Areas with the corrugations have to be milled off and replaced with the highly stable asphalt mix. And here there's some picture. It's not very good picture, but here there's a traffic light, and it doesn't. The corrugations may be not very visible. It's not a good picture, but there are some corrugations here because of the traffic light. Everybody is stopping and accelerating, and this might show some better example of corrugations here. Yeah. Here also there is a traffic light on the side of the camera. So these will mostly happen on the slope near the traffic lights. Raveling is a progressive disintegration of asphalt surface as a result of dislodgement of aggregate particles in the mix. There is a lack of sufficient cohesion due to low in-place density. Like it can start right away. If you got like 12% air voids at the time of construction, raveling can start like within a year or so. Lack of fines in the asphalt mix matrix, especially the coarse segregated area, aging of asphalt binder. The last point is very common because of the oxidation of the bitumen. Raveling can just be initiated. Here is a very bad example of raveling. Too much raveling has taken place. Now in this slide you can see that quite much of the fine aggregate has been lost, and the coarse aggregate particles are kind of sticking out. Although it will provide a very good skid resistant surface, but we are losing our surface because of the raveling problem. Now this is even a more severe case. Not only we have lost the fine aggregates, we have also lost some of the coarse aggregate. So it's a high severity raveling. Yeah.
Difference between raveling and stripping, both is loss of bitumen only. How we differentiate raveling and stripping?
Yeah, stripping will usually take place mostly from the bottom up, you know. It will start usually from the DBM. First the DBM will get stripped, and then the BC will get stripped. This one we are talking about only on the BC.
Surface,
Only surface, yeah.
But both are loss of bitumen.
Now the stripping, which is called hydraulic scouring, very rare, but can take place on the top also. But typical stripping will be starting from the bottom up.
You're not able to take a core. It will crumble.
Crumble, yeah. We'll show some picture of that. I think the next few slides we also. But this is just a surface thing, which we could do some preventive maintenance or do. We'll discuss in the next lecture what to do. Treatment of raveling. Something is here. Following treatment are suggested in order of severity of raveling from slight to severe. Apply fog seal with diluted emulsified asphalt binder, and we will discuss that in the next lecture as well. Apply slurry seal or microsurfacing, or overlay with dense graded asphalt mix, overlay with like a BC again. Here is just called scaling of wearing cores from binder cores. I have seen lot of scaling in India wherever we have put SDBC on top of BM. BM SDBC is very common in India because they are very cheap. BM is very cheap, SDBC is only 25 millimeter thick. So everybody does that. BM takes like lot of air voids, so it will take up all the water. So water will get filled, the stripping will take place, and there will be debonding between the SDBC and the BM. This is a case of, this is from Kerala, where SDBC has been scaled off. Stripping is the breaking of adhesive bond between the aggregate surface and asphalt binder, usually in presence of moisture. It will happen because of inadequate pavement drainage system, mixes with excessive air voids like BM, will be one example, or poor compaction or low asphalt binder content. BM has also very high air voids, also has a lower asphalt binder content. Incompatible aggregate surface and asphalt binder displaced by water, excessive pore pressure induced by traffic. If like BM is filled with water and traffic is plying on it, then I'm creating a lot of pore pressure, so it will also cause stripping. Spontaneous emulsification of binder by water, that sometimes happens on the surface. So here is a case of stripping in the US. I went there to investigate that, and this job was only 1 year old, and it has already started to strip. You see the black surface, a lot of patching was done. They kept on patching and it kept on failing. One typical, classical stages of stripping which don't happen on all the project is that first the DBM will start to strip. Somehow, the moisture is coming from the bottom up, like from WMM, it's going up, So first its effect, the DBM will start to strip. Strip means the bitumen film has been stripped off the aggregate. Aggregate looks like a clean aggregate. So what we see on the surface, first stage is we see some white fines. We see fines if their color is white, because in the DBM the stripping has taken place. So the aggregate has some dust coating or whatever. The moisture will bring out that dust, to the top of the surface of the BC. So we see white stains, and then eventually after a few months, the bitumen which was stripped off will start to migrate towards the BC surface. It always migrates up, because of some moisture, vapor, pressure or whatever. So then we see some black bleeding spot. You see this white surface here, and the black surface is the bleeding. And then after it starts to bleeding, then you start to see pothole. So I did get a picture here. I'll show you more close up here. Here you can see all the three stages. You can see white spot, you can see bleeding, and then there is a pothole. But this picture is more clear. Here you can see on the left side, you can see the white spot, white, and then this is a bleeding area, and there is a pothole. So these are classical example of stripping starting from the DBM. I've seen some projects here of national highways where DBM one layer is completely more than 50% stripped. Now you can just take your hand, dig out. What kind of support that will give you? Then I've seen the DBM grading, the upper level, which has 50% strip, and now BC is okay. So the pavement doesn't have any support, So stripping is really bad. Now that's the bottom of the binder course. That's the bottom of the DBM, and you can see all these white spot. It's all stripping, as if these particles were never coated. They appear like there was no. Again, example of stripping. This is a black aggregate, so you don't see that very clearly. But here the bare surface, you see the bare surface. And then the stripping will lead to potholes. Then one problem we have is the skid resistance. Is the friction between the tire and road surface is quantified by friction number, and it's very critical when surface is wet and makes it very slippery. When the surface is dry, the skid is not a problem. Only when rains, we have problems. That's why we sign. I don't know whether we sign in India. In the US, we have sign slippery when wet. So Here we don't have too much rain, only the monsoon. In the US it rains like almost throughout the year, you know. And the causes for low friction number will be the flushing or bleeding of the asphalt surface, that will result into low skid resistance, inadequate micro texture, which is the aggregate property, aggregate which are prone to polishing. Many of the limestone are very much prone to polishing, so they don't have good micro texture. The texture of the aggregate which is exposed due to after wear, the bitumen film is worn off, that's the micro texture. So that also contributes to skid resistance. That's why we test the aggregate for the skid. You know, we saw it yesterday, day for yesterday. Also, inadequate macro texture. Macro texture is the property of the mix. You know how open the mix is. Like stone matrix asphalt, SMA it has a good macro texture compared to BC, because if you have good macro texture, you have a if you don't have good macro texture, then you don't have drainage channel, you causes hydroplaning and importing at a high speed. The skid number goes down at high speed. The higher the speed, skid number goes down. Now this is a picture of a slippery pavement, but it's very difficult to take a good photograph of aggregate which has polished. No, but this is a really picture of.
The previous photo, we call it as stripping or it's a raveling.
Huh?
This photo.
Previous photo.
This one.
No, this one, yeah. That only. You see, Saki is traveling or stripping.
No, this one is nothing. It's not. It's a polished aggregate. You know, there's no raveling. It's not a good picture. It looks like might look like raveling, but it's a good BC surface. But all the aggregates are polished. You know. Yeah.
So it's not any.
It's very difficult to take a picture of to show that it's a polished or not polished. You know.
Low frictional number.
Low friction number. Yeah. Treatment for bituminous pavement with polished aggregate. All treatment should use whatever we use. You know, as a overlay, whatever it should be, contain the polish resistant aggregate. You will apply slurry seal or micro surfacing, apply surface dressing, or overlay with the new asphalt mix. So this is the last slide. That means, you know, we should have a asphalt pavement which should be free of all the pavement distresses. Now this one I just took. You know, when we are trying to investigate pavement distress, you have to walk on a pavement slowly and see, you know, how many cracks you have, where the problem is. This picture came from the US, where the PWD people, they were doing the striping. You know, they put the striping on the animal without removing it. You know, a typical government here. Those you see very unusual things. You know, when you walk along the road. You know, yeah. You also see beer cans and all those kind of stuff.
Yeah,
You know, lot of things. You know, unusual thing here, but sometimes you see.
Even US also it is.
Huh?
Not only in India, US also is like that.
Yeah.
Government is government, whether it is in
Yeah,
US
government
or
is
India.
government, whether it's in the US or anywhere else. You know.
Yeah.